today we're just going to do some introduction and filling in, what we're going to be covering for the semester. For those of you that had me last semester, you know that I do record my lectures and I post them on YouTube. They're usually available the following day sometime. So if you miss a class or you want to go over something again, you can go to YouTube and watch the video of the lecture. I do edit the video, so roll call is not in the videos. So that is available for you. What are we going to be covering in this class? Number systems. Basically how to count in different bases. We typically use base 10 for counting because we have 10 fingers. It's natural to use a base 10 number system. We also use the base 60 number system for telling time. You count up to 60 and then you carry the 1 into the minutes. Count up to 60 minutes, carry the 1 into the hours. That's a base 60 number system that we get from the Mesopotamians, ancient Mesopotamians. But we'll go into more detail on the different number systems that computers use and how to count and do math using those number systems. The basic digital logic gates. There are 7 basic digital logic gates. We're going to focus on the AND, OR, and inverter. Those of you that had discrete structures already got a brief introduction to those in that class. And we'll cover the other 4 logic gates as well, if not thoroughly, but at least briefly. Boolean algebra, how to manipulate these logic gates in a mathematical fashion to reduce the number of gates being used, predict outputs, that sort of thing. Gate minimization, there's different techniques for gate minimization. Each gate adds a little bit of delay into a system, so you want to minimize the amount of gates used to perform your logic. Gates also cost money, so each gate you can reduces the cost of the system that you're developing. Combinatorial and sequential logic are ways of linking the basic digital logic gates together to perform different functions. We'll get into those toward the end of the semester. All right, what you need to know. You should take notes, ask questions, and very important, communicate with me. I will allow notes on quizzes and tests. I do not allow devices to be used. No tests or quizzes are on Canvas or anything like that. Just paper quizzes and tests. You and your notes. So if you have notes on a tablet or something like that, print them out. They have to be on paper. Like I said before, video record the lectures. They're generally available the following day on YouTube. When they're available, I post the link in an announcement on Canvas. So you can get caught up or review using those. And I will be available outside of class. I'm here most days by 8:30, 8 or 8:30. And I have classes until 4:30 or 5, 4 days a week. So I'm here pretty much full time. The system I have with my office is, if I'm in the office, the door's unlocked and the light's on, of course. If the light is on and the door is locked, that means I'm typically in class. If the light is off, I'm off campus. But if I am on campus, the light is typically on in my office. All right, let's see here. What makes up your grade? Attendance, 10%. I was editing some slides and not quizzes and labs. Quizzes are 25% of your grade. In-class tests 25 or 20%, midterm 20%, final exam 25%. I don't plan on having homework. If I do issue some homework, it will be included in the 25% quizzes and labs. Like I said, I got this class like 2 hours ago, so I slapped this PowerPoint together pretty quickly. What you should be doing this semester: attend class. Getting a good grade is virtually impossible if you do not attend class. Got to stay up to date about what's going on. Be there to ask questions if you don't understand a concept. If you do have to miss a class, let me know. We'll get you caught up, keep you up to speed. You know, shouldn't be too much of a worry. Take notes. Taking notes helps you absorb the material. Translating what you see on the board and what you hear when I speak, translating that to notes written down, typed in, whatever, requires you to process the information, which helps your ability to retain that information and understand it. And you'll be allowed to be using those notes on the quizzes and tests. So there's a lot of material. I can't think of an engineering or computer science type of job that wouldn't let you have reference. So you shouldn't have to memorize everything. It's just not feasible, not realistic. Ask questions. If you do not understand a concept, I can reword it and re-express it in a way that maybe will help. If you do not ask questions, I don't know there's a problem. So be sure to ask questions. Taking notes. Processing it. Organizing them so you can find the information you need easily and quickly. How you organize your notes might be different from how your neighbor organizes their notes. It's what makes sense to you. That's part of customizing your educational experience. What works for you? Are you a verbal learner, a visual learner, a kinesthetic learner? These different learners will take notes and organize them differently. So organization is important. And again, they're allowed on tests and quizzes. Let's see here. What I will do, allow notes, record lectures, and be available. If there's more that I could do besides these three things, please let me know. I've been doing this for a few years, but I can definitely say I don't know it all. You know, I can always improve. Each semester I learn something, and am willing to adjust things as the needs and environment changes. There's been, you know, advances in technology and all that sort of stuff, like the increased presence of AI in available on the internet and that sort of thing since I went to school. You know, so that needs to be taken into consideration, because that is another tool that you guys have available to you that I didn't have when I was in school. So we're constantly needing to adjust, constantly needing to update how we present things, how we take tests and quizzes. So, you know, if there's something more that I can do to help, please let me know. I am understanding of special circumstances. If you need special accommodations, let me know. Disabilities, sports, band, student organizations, travel to conferences, interviews, that sort of thing. How many athletes do we have in here? Anybody? Not a one? That's weird. Band? Ah, there we go. I understand travel with band is an important part of the being a part of the band. So just let me know when you're going to be out, and watch for the videos on YouTube. If you have to be out when a quiz or test is scheduled, I will work with you on getting a makeup test either before you travel or after you get back. I understand a lot of athletes and band members are on scholarship with those organizations, and you got to go where the money is. You know, you gotta fulfill the requirements of your scholarships and all that sort of stuff to stay in school. So I definitely understand that, and will be happy to work with you on that. Student organizations, I understand those have time commitments. If you get to travel to conferences, which I highly recommend, that's understandable that you miss job interviews. Typically, it'll be toward the end of the semester for interviews for internships and that sort of thing. They have a career week in the fall and the spring, I believe. Attending that is, again, understandable if you have to miss for that. But yeah, I'm easy to work with. Would my previous students agree that I'm easy to work with, or okay? I try. You know. Any questions for me? Yeah. I'm trying to remember. I think it's a Casios calculators have number systems conversions. The TI calculators, I believe, do not. I don't remember. It's been a while since I've looked at them. I'm sorry? It depends on the model of the calculator you get. but it's I believe it's Casio calculators. You can convert binary to hexadecimal and decimal. But when we first cover that, we're not going to be using calculators. We're going to learn how to do it by hand, which is a little tedious, I understand, but hopefully it'll become old hat without too much difficulty there. Let's see here. That's my email and my office hours, official office hours. My phone number, that's my cell phone number. Don't abuse it. That is my personal cell phone number. So if it's an emergency, you can text me, that sort of thing. But, please respect normal waking hours. I don't need calls at 2 o'clock in the morning of frantically trying to figure something out before the final. Don't need that. But anyway, any other issues, questions? There is a textbook. I don't have it yet. I recommend getting the textbook. My personal approach to the use of AI is, I don't think it'll be an issue for this class, but for fundamental courses where you're learning the basics of something, you shouldn't use it. You should learn the basics of how things work. Because AI will get things wrong, and you need to understand the concepts well enough to know when the AI is getting it wrong. So, your computer science 118, 119, digital logic, discrete structures, that sort of thing, you shouldn't be using AI. You should be focusing on learning the concepts so you can do them yourself. Later, I would say in your junior and senior years, you can use, I would say, if I were the professor at least, of the class, you could use AI as a tool. Not to do the work for you, but I do software development as a side job, and I use AI all the time, not to write code, but rather to debug code. Code's not working the way it should. I can't find a solution quickly. I'll dump it into ChatGPT and say, okay, this line of code is wrong, and see what's going on and adjust it and fix it. That's perfectly okay. But when you start using AI to generate solutions, there's ethical and even legal considerations that are present. When AI generates a piece of code, who owns the code? You, the AI, the people that develop the AI. Who has the legal right to use that code? Whereas if you're using it for debugging, like, you're writing the code and it suggests a change here or change there, it's still your code. It's just been fixed and a little tweaked by AI. Writing papers, they have software that detects the presence of an AI generation and that sort of thing. And when you go to when a professor goes to grade them on Canvas, you can get a little report that says, so much percent AI generated, or 85% plagiarized. You know, AI is a tool. It's around. It's not going anywhere. So embrace it, but realize it has limitations. It doesn't always give you the right answer. I especially have issues with it with generating code. Since most of you in here are computer science majors, using it to generate code is not, it's not a good thing. Yeah, the ethical and legal issues aside, it just, doesn't generate good quality code, modular code, maintainable code, that sort of thing that you need for assignments and when you get out into the workplace after college. So anyway, well, what time is it? My phone's, I'm sorry? 12:27? Oh, okay. I only used up half the class. All right. Well, I suppose we can start with a little bit of number systems, since that's the first section that we're going to be covering. Number systems. Number systems have a base. We use base 10. What? I'm beginning to dislike these smart boards. Not too terribly smart. Why are you doing this? Is this one? Are you going to go shut down again? You are going to shut down again. Why is this behaving like this? I'll use the traditional whiteboard. It does have coverage on the phone. I checked that before. But base 10. The base refers to the number of symbols used to represent numbers. So base 10, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 symbols. Okay? If you have base 16, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. If you have base 2, you have 0 and 1. The number of the base is the number of symbols used to represent the numbers. Pretty simple. When you we'll get to base 16 a little bit later. We'll just stick with base 10 for right now. Get into the actual mechanics of counting and representing numbers. When you are counting, you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You run out of symbols, you just add 1 to the next column and start over. So that's why you have the 1, 0, 1, 1, 1, 2, etc., etc. When you add, if you add two numbers, say 5 and 6, it's like counting past 10. You carry the 1 and start counting over from 0. So you go to 5 plus 6 is 10, plus 1 is 11. Yeah. I know this is stuff that you pretty much covered in what, second grade? But the mechanics of it are what we're going to expand on into different number systems. The places that you have numbers, or your symbols, are the 10 to the 0, 10 to the, in base 10, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. See a pattern? Start with 0, and the base number, you raise it to that power. So what's 10 to the 0th power? 1. So that's your ones place. This is your 2s. I'm sorry, I'm thinking base 2, not base 10. This is your 10s place, because 10 to the first is 10. This is the hundreds, thousands, and 10,000s. So on and so forth. Okay? But your base is what you're raising to each power. And the position you're giving it is counting up as you count to the left. Now, you could also go to the right, and you would count -1. Let me get this out of the way here. No. 10 to the -2, 10 to the -3, etc., etc. So this would be the 0.1, 0.1s, 0.01, 0.001. Pretty simple stuff. That's how you break down a number. So you have 384.28. It's 3 times 10 to the second plus 3 times, plus 8 times 10 to the first plus 4 times 10 to the 0th plus 2 times 10 to the -1 plus 8 times 10 to the -2. Broken down into its component parts, a number can be expressed as in its powers of the base, this being the base. Pretty simple stuff. It's not rocket science. They save that for your junior and senior year. Yeah, that's how base 10 works. As you can imagine, you can have any number as a base. Typical bases used in computers are base 2, which is called binary, base 16, which is hexadecimal, called hexadecimal, and in some older computer systems, you'll run into base 8, which is octal. That's not very common anymore. People don't typically use octal in notation much anymore. Haven't seen it in quite a number of years. But if you work on an old legacy system, you might run into it and just know it's there. But yeah, that should basically cover it for base 10. Any questions as to how base 10 works? How you've been counting since you were knee-high to a grasshopper? Yeah, pretty simple stuff. Like I said, it's just second grade, third grade stuff. Yeah. But we'll get into the other bases next time. We'll go ahead and call it a day for today, and we'll start covering binary on Wednesday. So if you came in late, come see me about the roll. Have a wonderful day.